Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to lecture 6 of Organic Chemistry 2. Today we will start on chapter 2, Aromatic Compounds. We will give an introduction to aromatic compounds and cover the nomenclature of benzene derivatives. Many derivatives of benzene were originally isolated from the fragrant balsams obtained from trees and plants, and these compounds were therefore described as being aromatic in reference to their pleasant odors. Aromatic compounds are produced from a variety of sources, including petroleum and coal tar. Polyaromatic hydrocarbons are components of atmospheric pollution and are known carcinogens. Nowadays, we can obtain aromatics from reforming and refining petroleum, as well as heating coal at temperature higher than 1000 in the absence of oxygen to give coal tar, which contains variety of polyaromatic hydrocarbons. How we can name these compounds? If we have monosubstituted derivative of benzene, the monosubstituted benzenes named systematically using benzene as a parent. Benzene, 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 and listing substituent as prefix. So here we have Cl, so it's chlorobenzene. We have Br, so it's bromobenzene. NO2 group, it's nitrobenzene. CH2, CH3 ethyl group, so it's ethylbenzene. Some monosubstituted aromatic compounds that have common names accepted by IUPAC. So the common name of several aromatic compounds, monosubstituted, are still used and acceptable by IUPAC systematic nomenclature. If we look there for the benzene has an OH, IUPAC should be benzenol, OL. But the common name is phenol and is still accepted by IUPAC name. Here with NH2, this is benzamine and common name aniline. Here is a methoxy group, we call it methoxybenzene, but we can still name it anisole, common name. Here is methylbenzene, and we can still use toluene. Here is vinylbenzene, styrene, common name. Here is benzaldehyde, acetophenone, benzoic acid as a common name, and these names are still in use. IUPAC here, ethynylbenzene, phenylacetylene, common name. Benzene ring with SO3 called benzene sulfonic acid. If the substituent is larger than benzene ring, I mean has more than 6 carbon atoms, or contains superior groups, then the benzene ring is treated as substituent and is called phenyl group. Here on carbon number 1 of octane we have phenyls, that's why it's 1-phenyl octane. Here we have this ketonic functionality on number 1 of ethanone, so it is 1-phenyl ethane 1-on. Disubstituted derivatives of benzene are named using prefix ortho, meta, para, abbreviated OMB. Numbers can also be used to specify the substitution in disubstituted benzene. So if you have X and Y, here is 1, 2, or ortho. Here is 1, 3, or meta. Here is 1, 4, or para. IUPAC systematic name for this compound is 1, 2, both methyl groups, so it's 1, 2 dimethylbenzene. By common name we can call them orthoxylene. Here is 1, 3 dimethylbenzene metaxylene. Here is 1, 4, and that's 1, 4 dimethylbenzene or 1, 4 xylene or paraxylene. For this compound, that's 1, 2 dichlorobenzene or orthodichlorobenzene. There is no common name. Here we can call this 1 and 2, or we can call them 1 here and 2 here. So the number is 1, 2 in both cases. So we have to arrange them alphabetically. So the 1 bromo 2 chlorobenzene will be the correct name. This will not be correct. 1 bromo 2 chlorobenzene is the correct name. If we have like this one here is phenol, so the parent will be phenol, and this will take number 1, so that's 1, 2, so it will be 2-chlorophenol. For polysubstituted derivatives of benzene, when there are more than 2 substituents, numerical locants are used to specify their location. In cases where the root name can be defined using common aromatic names, which is typically used, we define that and we give that function group here C1. And the other substituents are numbered such that they get the lowest possible sum. If there are more than 2 groups and numbering doesn't make a difference, start with alphabetical priority and number the ring toward the next alphabetical priority. After we give the number and we give the name, we write the substituents alphabetically, regardless the number they have. Here we have brom, NO2. So I name it here 1 bromo, 2 bromo, 5 nitrobenzene, because I count them or number them counterclockwise 1, 2, 3, 4, and 5. I also decided to give, I don't know why, but give the nitro number 1, that's 2, 3, 4, and according to this number will be 3, 4 dibromo, 1 nitrobenzene. Well, both of these numbers 1, 2, 5, that's 8, 3, 4, 1, also again sum 8. But if I number them 1, 2, 3, 4, so the compound will be named 1, 2 dibromo for nitrobenzene, sum of 7, 1, 2, 4, and that is the shortest number, so this one will be the correct name. Here we have phenol. right? So this will be number 1, counterclockwise 1, 2, 3, 4, and here clockwise 1, 2, 3, 4, 5. According to this, the name will be 3,4-dibromophenol, 3 and 4, 7. Here is 4,5-dibromophenol, that's 9. This is the correct name. For this one again, if we have NH2 on benzene ring, this is aniline. Number it 1, 2, 3 clockwise, so the substituent will be 2-ethyl 5-nitro, 2-ethyl 5-nitro. If we get it counterclockwise number system, 1, 2, 3, 4, 5, 6, that's ethyl will be 6 and nitro will be 3, and number some 9. Here some 7, 2 and 5. So this is a small, this is wrong. This is the correct name. Aromatic hydrocarbons are sometimes called arenes, like when we call alkenes. Here we say arenes. And aryl group, abbreviated AR, is the aromatic group. We were saying R for alkyl group. Here we have AR for aryl group. So after the removal of hydrogen from benzene, we call the group phenyl group. If we have toluene and we remove H, then this is a benzyl group. And we have an OH in here, we call it benzyl alcohol. For this compound, we have 3 substituents, Br, Cl, and NO2. And the number system will be 1, 3, 5. Or if we give the Cl 1, 3, 5, or in other case we'll give 1 for nitro, 1, 3, 5. So in the 3 cases we have 1, 3, 5, sum of 8. We select the 1 for B, 3 for C, and then the higher alphabet N will take 5. So this is wrong, this is wrong, this is wrong, this is wrong, this is wrong. This one is correct. We give the lowest to the lowest number for the start alphabet, B. Okay? And 3 for C, and 5 for N. Name the following compounds. We have fluor on benzene, so that's fluorobenzene. Here we have more senior alkyne butane. Butane is here 1, 2, 3, 4. On number 4 we have a phenyl group, so this one will be 4 phenylbutanene. Here we have phenol as parent, so this will be number 1, and the substituent methyl will be number 3. So this is 3-methylphenol or meta-methylphenol, and the common name metacresol. Here this compound is styrene. Well, this is number 1 then, and this is 2, so that's 2-nitrostyrene or orthostyrene. For this compound we have here isopropoxy group on benzene, so that's isopropoxy benzene, or isopropyl phenyl ether, For this compound, we have benzene. What about this one? This is methyl, and this is ethoxy. So these pieces will be ethoxy methyl benzene, ethoxy methyl benzene, or we can call this benzyl ethyl ether. For this compound here we have anisole, so the methoxy here will take this carbon will be number 1. So this is 2 chloro, 2 bromo, 4 ethyl, 1 methoxy benzene, or 2 bromo, 4 ethyl anisole. Physical properties of benzene and its derivatives. Benzene derivatives tend to be more symmetrical than similar aliphatic compounds. They pack better into crystals and have higher melting points. So if they are symmetric, so they pack better into crystal structure, so they have higher melting point. For example, benzene melts at 6 degrees Celsius, while hexane melts at -95 degrees Celsius. Similarly, para-disubstituted benzene are more symmetrical than the ortho and meta isomers, and they pack better into crystals and have higher melting point. The relative boiling point of many benzene derivatives are related to their dipole moment. For example, dichlorobenzene have boiling points that follow their dipole moments. The symmetric para-dichlorobenzene 0 dipole moment and the lowest boiling point. So here is 170 boiling point, and the ortho is higher 181, and again el meta is higher 173. Dipole moment of the para analog has 0, so has the lowest boiling point. The meta has a small dipole moment and slightly higher boiling point than the para 1. Orthodichlorobenzene has the largest dipole moment and the highest boiling point, and has the highest boiling point. Even though para-dichlorobenzene has the lowest boiling point, it has the highest melting point. As a general rule, the more symmetrical molecule, the higher its melting point, and the lower its boiling point relative to its isomers. See you next lecture. Bye.